Very good evening to everyone who has joined this live session. My name is Rajkumar Pant, and I'm happy to be here to take any queries or any doubts that you may have. After that, we will go for a small presentation on some activity which is happening in the near future. So the floor is open, friends, for any questions or any queries that you may have regarding Introduction to Aerospace Engineering Flight. Mitraditya, thank you so much. You are starting off today's evening with a very positive comment about my teaching. So thanks a lot. Anybody else would like to ask any question or comment on anything? Also, there is a comment from VVM. I don't know your full name. You have mentioned that I am very knowledgeable and very humble. Thank you so much for your positive comments. Actually, that is not true, but still, I appreciate your comments. Very good. Mitraditya has a very interesting question. Difference or relationship between drag divergence Mach number or DDMN and critical Mach number, M critical. Okay, so, the TA Namaruddin is saying wait. I don't know why he's saying wait. Is there a problem, Naman? Naman, please confirm that things are okay so I can start answering the question. Okay, never mind, Naman. It's a question from the assignment. Okay. All right. All right. Okay, fine. So I think if it is a question from the assignment, then I think it is better that it should be handled by you yourself and not by me in the session here. Yeah, thank you. Thank you, Naman. I think he is trying to verify. Okay. So this is something that will come in the future. So I would not like to answer the question regarding that. So we will wait till Naman checks and reverts back. In the meantime, I'd like to thank Rohit Kumar again for some appreciative comments about great learning experience. Thank you. As a faculty member, I also feel very happy when I get a feedback from students that they are learning as we learn. So remember that teaching itself is a very, very good learning experience, and we learn every time. Every time we teach, we learn. And we also enrich ourselves more and more when there is an interaction. And that's why I really enjoy these interaction sessions. Only thing is that I don't get many interesting and pertinent questions. Many questions which are asked in these sessions are related to which IIT is better for aerospace engineering, or should I do MTech in India or abroad, etc., etc. I mean, kind of out of syllabus, Okay. So that's fine. I mean, I appreciate your queries and your questions, but it will be nice if you can use these sessions to get clarifications regarding various topics in aerospace engineering which have not been covered in the class notes or in the course, because it's a very vast field and it is very difficult, almost impossible for someone to cover all the aspects of aerospace engineering in just one course of 30-40 hours. So therefore, these online sessions are essentially aimed at interacting with the students and trying to get an idea about any queries or any questions that they may have, which are pertinent to the topic, and also maybe there are certain topics which have not been covered and hence you would like to. Okay, so I have the clearance from Naman regarding the drag divergence Mach number and critical Mach number. So friends, critical Mach number is the Mach number of the free stream at which the sonic conditions are first experienced anywhere on the aerofoil or on the wing. So as you know, the flow accelerates as it goes over an aerofoil or a wing. And because of the local acceleration, the velocity of the ambient air increases compared to the velocity far upstream from the body. So this acceleration can lead to a situation where the flow over the aerofoil or the wing becomes supersonic. So the free stream Mach number at which sonic conditions are first experienced anywhere on the aerofoil, usually on the upper surface, but it could be anywhere on the aerofoil, that free stream Mach number is called as the critical Mach number. It is critical because sonic conditions have first been reached. Now, what is the problem with sonic conditions? The problem is that just after slightly more than the critical Mach number, there is a Mach number called as a drag divergence Mach number, at which the drag, the parasite drag, starts increasing rapidly. It becomes exponentially high. So the critical Mach number is a Mach number slightly below the drag divergence Mach number. But the drag divergence Mach number is more important or more relevant for a designer because that is the Mach number at which that is the free stream Mach number at which there is a substantial increase or there is a start of substantial increase in the drag. So flying beyond DDMN, drag divergence Mach number, is absolutely undesirable unless you want to exceed the sonic limit and go to supersonic. Then of course you have no choice, but you have to be ready because there will be a huge demand on the thrust of the engine as you go beyond critical Mach number and as you approach the drag divergence Mach number. The difference between the two is very, very small. Sometimes it is 0.1 Mach number or 0.2 Mach number, very small amount. Okay. So the drag divergence, so just because there is a sonic condition does not mean that there will be very high drag. Slightly beyond the critical Mach number is a Mach number at which the drag starts rising exponentially. It diverges basically. And that's why we call it as a drag divergence Mach number. Okay, so I hope you have been able to appreciate the difference between the two, DDMN and CMN. In short, CMN is always less than DDMN, but less by a very small amount. Both of the values of critical Mach number and DDMN, they are below 1. Okay, Mitraditya says, if we can interact and have a session in IIT with you, it will be great experience. I'm a qualified rotary wing engineer serving in the army now, Lieutenant Colonel. So Colonel Dasgupta, I'll be very happy to interact with people in IIT Bombay. Recently, there was a session which was conducted, but unfortunately it was online. 2 Saturdays ago, on 3rd of September, I interacted with the prospective students who have just appeared in JEE Advanced and now the results have been declared. So there are many students who wanted to know about aerospace engineering, the plus, the minus, the career prospects, etc. So definitely we will be happy to arrange a face-to-face interaction session. What you can do, Colonel Dasgupta, is just send me an email. I have a lot of armed personnel in my class. There is also Colonel Balendu from the Indian Army sponsored for MTech. And there are many others. There are at least 10 to 12 defense personnel in my MTech class. So I'll be very happy to interact with you. And I'll be very happy to, if you want, we can organize a session. Just contact me via email and we will be happy to try and arrange the session. We could invoke the help of the Mumbai branch of the Aeronautical Society of India, of which I'm a very active member. And I'm also a member of the National Council of the Society. So easily we can arrange an interaction session in Mumbai. Yeah, so Colonel Dasgupta, as Noman has said, please write to us and we will be in contact. Okay. Chesi Parashar has a very interesting question. Why in some aircraft we have altitude restriction on flaps operation, but only Mach number limitation on landing gear operations? Okay. Interesting. So generally what I am aware is that there is a limitation on the forward speed for flaps also. In fact, in the airspeed indicator, there is a white arc, and that white arc, the limit of the white arc is the highest speed, the highest indicated airspeed at which the pilot can deploy the flaps. Okay. So there is a upper limit on the deflection of flap. And similarly for landing gear, both of these, landing gear as well as flaps, when you deflect them or when you bring the landing gear down, it leads to extremely high drag. And the drag forces could be so large that they can cause structural damage. In case of flaps, they are generally mounted on flap railings. And most of the flaps for transport aircraft tend to be a Fowler flap, which, as you know, moves back as well as down, so that there is a effective increase in the flap area along with the deflection. Now it moves along those railings, and there are motors which deflect the flap down, and there is a limited load that the motors can handle. So if you deflect the flaps at very high speeds beyond the critical speed, the load on the flaps may be so high that it will lead to shearing or breaking of the flaps. And the same is true for landing gear, because landing gear has a very large frontal area, and that is going to create a direct moment on the junction of the mounting of landing gear onto the aircraft structure. So therefore, we always specify limits. Now, I'm not aware about limits on altitude restriction on flaps. I'm not immediately aware about that. But my understanding is that there is a maximum speed limit or Mach number limit for deployment of both of them. Okay. Sanket Bhatt has a question. When we deflect any control surface, both CDO and K will change. Which will change more out of them, and how to identify? So obviously the CDO will change drastically, because CDO basically represents the parasite drag. And when you deflect a control surface, the parasite drag is going to increase more. Okay. Now the induced drag basically is a function of the wing aspect ratio and on the Oswald efficiency. Now that does not change too much. Okay, the Oswald efficiency, definitely there might be a slight change when you deflect, but the aspect ratio does not change when you deflect any control surface. Therefore, prima facie, to me it seems that change in the CDO will be much more than the change in the value of induced drag factor. Mitraditya has a question about stagnation pressure arise only in isentropic conditions. No, that is not true. See, isentropic conditions are basically theoretical conditions. Okay, we assume those conditions to make our life easy in certain scenarios, but the stagnation pressure will rise in both the conditions, in all the conditions, not only in isentropic conditions. Okay. Very good. I'm very happy at the beginning of this particular session. There have been very good questions. So I would urge you to please continue asking your questions, and don't feel shy. No question is stupid or no question is foolish. Okay. Any question can be asked, and sometimes you will realize that the question that you ask, it may seem very stupid to you, but it may be a very good question. And also more important is, there may be some other person in the audience who is a bit shy or reluctant to ask a question, but he or she may have the same doubt. So you are actually helping somebody by asking your question. In many circumstances, we come to know that the question that is asked by a student is actually the question in the minds of many people, but few people are hesitant or shy to ask. So please ask any question that you may have. Okay, Avinash Mishra has a question. This is not to do with aerospace engineering, but it is to do with the gate examination. He says that he has cleared gate 2022 with AIR 49 in third year, and he's searching for good internship. Can you guide me about the same? So Avinash, most of the academic institutes of repute in the country, for example, IITs, IISc, they do have a formal internship program. I'm aware about the internship program of IIT Bombay. Unfortunately, You could have taken part in that, but you have missed the deadline because I think the deadline has already crossed. We are now supposed to shortlist people and submit. Similarly, there is a program in IIT Kanpur, I know. There is also a program in IIT Madras, and I'm sure there are programs in other IITs. So, best is to appear for internship interviews and get internship under these programs. However, I know it is difficult because there are restrictions and there are constraints. The next option is approaching the concerned faculty members by sending them an email. Now, the reality is that if you send 100 emails, 90 of them will not be answered. Out of the 10 people who answer, maybe 6 will say no. Out of the remaining 4 people, maybe they will say, okay, let me get back to you. And maybe 1 or 2 will actually offer you internship. But there is no other option. You have to try out. There is no obligation on a faculty member to really offer internship. We normally propose an internship under our standard programs. For example, in IIT Bombay, we have what is called as IRCC research internship. And Namanuddin, the teaching assistant of this course, has been a recipient of that internship award. So you can consult him also. He is available to you in the discussion forum. Currently, he is pursuing a master's program at IIST near Trivandrum in Valiamala. But he is available to you in the discussion forum to answer. Chasey has another question. Why does the efficiency of jet engines increases at higher altitudes, although the density of air falls as we go higher? I'm not sure if this is the correct question. I'm not sure whether the efficiency of jet engines increases at higher altitude. In fact, my understanding is that as you go to a higher altitude, the thrust available reduces. Right. Muhammad Abdul Aziz, very good. He has a question regarding lecture 11 in Quanda effect. You have some relevant material for preparation of the flying saucer. He is very much working the project. Okay, so look, Muhammad Abdul Aziz, I don't have any special material on that. In fact, I had only searched on the internet, especially on YouTube. I found a small project by someone on the Quanda saucer, Quanda effect saucer, and I just shared that in the course. So really, I don't have any other material on that. I would like you to search like me and like the teaching assistants who work with me to locate information online and take it from there. I don't have any special information about the Quanda saucer. But I'm glad that you are getting motivated to work on the project. And in fact, maybe Nauman can help you in that. Be in touch with him and he should be able to give you some information about that. But sorry, I don't have any other special information about Quanda effect saucer other than what I have shared on the course. Some of my students in IIT Bombay also who attended the course got inspired, but I don't remember whether they are able to make it or not. Sanket Bhatt has another question. Stall velocity changes with altitude. But why not stalling angle of attack? Very good question. The stalling angle of attack is a function of the geometry of the body. It is not to do with the altitude. Stall velocity changes with the altitude because of the density change. Okay, but angle of stall is not going to affect based on the altitude because that is purely a geometric parameter. Vitraditya, how to distinguish between Quanda and Bernoulli? Both are similar. Quanda effect means sticking of molecules on surface of an aerofoil, but how to differentiate? Bernoulli's principle is generally applicable in a fluid stream. Either it is internal flow or external flow. Okay. And there you have to look at streamlines and you have to apply it across along a particular streamline. Many people make the mistake of applying Bernoulli's principle across streamlines. And that is what I have explained in my lecture on the fallacies about lift generation. As far as Quanda effect is concerned, it just talks about bending of the flow field because of attempt of the fluid to stay attached onto the surface and to continue moving. Even when you go beyond the curved surface, it continues to follow the curvature because of the pressure which acts. So That is how I would distinguish between Bernoulli and Conda. They are very similar, I completely agree. But one of them talks about the relationship between, see, Bernoulli's principle is essentially conservation of energy. So it just tells you that if there is a pressure energy and then there is a kinetic energy, if you forget about the gravitational energy, then you have the same height. Then basically the summation of the two energies is conserved. That is what is basically the Bernoulli's principle: conservation of energy expressed as a summation of the various energies while ignoring chemical and other energies. Quanta effect, on the other hand, is an observation that when the flow is made to flow over a curved body, it has a tendency to stick to that body and to continue in that curvature. That's the only difference between them. So when you apply Bernoulli's principle on the aerofoil, you are actually applying it across streamlines, which is wrong. So, yes, you can say that on a particular streamline, there is a loss, there is a drop in the pressure because of increase in the velocity. But when you apply across the streamlines, you are applying it wrongly. So that is what I have also mentioned in my presentation. Sanket, you are asking a question about lift coefficient of aerofoil depending on chord length or just shape geometry. Well, it's a very, very basic question. See, lift coefficient and lift are two different things. Okay. So when you look at lift, how much lift is generated, the chord will come into play, because larger the chord, basically more the area which is under touch with the flow stream potentially, if there is no separated flow, and therefore higher will be the lifting force. But when you have lift coefficient, you divide the lift by half rho v square and s, or in the aerofoil it is c, assuming unit span. So lift coefficient is a function only of shape or geometry. It is not a function of CL. Otherwise, when you look at the aerodynamic behavior or CL of a model in a wind tunnel, and with that you predict the CL of the actual aircraft, if there was a chord effect, then you cannot do it. So chord has no effect on CL. It has effect on L, but not on CL. So my request to you is that if you don't ask questions which are asked in the assignments in this particular session, because this session is not meant to help you in doing your assignments. For clarifications regarding questions in the assignments, please use the discussion forum, because our teaching assistants are very eager to sort out your queries. Okay. Use this session, the interaction session with me, to ask questions which are not relevant or not already addressed in the course material. Okay, let us keep the momentum going. So I'm waiting for further questions that you would like to ask. Okay, guys, keep your questions coming. We have another nearly half an hour to interact. Okay, so let me ask you some questions. So I would like to know, among the people who are present, I would like them to type out in which college they are and which branch they are studying and which is the year in which they are studying. Will using an afterburner in like 100%. Afterburner is not to be used more than essential, because it has a drastic effect on the engine life. In fact, uh, many a times it is clearly mentioned that if the afterburner has been used for more than a particular time, the engine has to be actually inspected, and many parts may have to be replaced because they will be worn out or damaged. So yes, in many transport, in many military aircraft, for example, I remember having worked on MiG-21 and MiG-27, there was a limit that during takeoff, afterburner can be used only for so many minutes, 3 minutes or 5 minutes. And in fact, if the pilot uses afterburner for more than that time, due to some reason, they have to actually report it. And the standard procedure was to inspect the engine for any damages. So yes, um, using an afterburner definitely will reduce the engine life. Okay. KC Parashar has a comment about lecture on generation of it was mind blowing. I had never heard of streamlined curvature. Wonderful lecture. Actually, Chesi, the motivation for that lecture came basically because when I was a student, I also used to believe what was told in those standard textbooks that this equal transit theory. This is what I was taught when I was a student, and I grew up with that particular story for many years. When I actually came to know the reality, I was shocked. I was personally shocked, and I said, why is there such a blunder available in textbooks? Then I came to know it's not a problem only with textbooks, it's a problem also with flight manuals. It's a problem also with standard procedures, standard training manuals which are given. And then I came to know that the problem is very, very prominent. And that's why I thought I will definitely record a lecture where I will talk to people about the errors or the fallacies which are very, very common. And then I came to know that even NASA has a page dedicated to these fallacies, which is what I have already mentioned, which I also mentioned in my lecture. So thank you, Chesi, for your very positive comments about the lecture on streamlined curvature. That is also something new for me when I came to know. In fact, in the year 2010, in 11, sorry, there was a visiting faculty in our department, okay, who came to teach aircraft design. His name is Scott Eberhardt, Scott Eberhardt. So Scott Eberhardt has worked in the Boeing Aerospace company for about, I think, 20 years. He had worked at that time. And then he had spent 5 years in University of Washington, I think. And then he has a lot of interest in going to various institutes all over the world and teaching aircraft design. So in his book, he has clarified this particular fallacy. And that's how I got inspired. Pratik Jalan is one of my very favorite students, and he has a question about which disadvantage of ramjet leads to improve it from scramjet. Okay, so there's no disadvantage. Basically, the scramjet is nothing but a supersonic ramjet. Okay, so when the flow exceeds a very high, so there is no disadvantage. Only problem is that in scramjet, you have to also keep in mind that the flow might dissociate because of extremely high heat. Okay. So I would not call it as a disadvantage. I would just say that they are like brothers. Scramjet and ramjet are like brothers. Scramjet is a supersonic combustion ramjet because when the Mach number of the flow increases beyond a particular value, the heat generated is so much that it can automatically cause it can cause the combustion. And therefore, that heat generated is what basically differentiates. Okay. So Naman has made a very interesting point that if you ask your queries in advance, then it gives us to some masala to prepare. So we could have come prepared with some PPT with containing information about your questions. For example, if I had got the questions in advance, I might have been more prepared. When I came today for the session, I was told that there aren't many questions asked by the students on the online session. And therefore, I don't have any presentation to talk to you. Okay, but keep your questions going. Keep your questions going. Thank you so much for such wonderful questions, which also make us think. And we also learn. In fact, many things in our mind get refreshed. Many old memories come alive. For example, I'm glad to remember my friend Scott Eberhardt today, thanks to the comment given by chassis pressure about the streamline curvature. Okay. So if you want to know more about the lift generation procedure, I would strongly recommend a book by Anderson and Eberhardt. It's a very good book, and it has got a nice explanation about all these issues. Okay, guys, keep your questions coming. And as I mentioned to you, I would like you to type out against your name the college where you are studying and which year you are studying and also which branch you are studying. Okay. Mitra Aditya has another question. Can you clarify between density and pressure altitude when we use it? Okay. This is a very interesting question. Basically, density altitude means the altitude under ISA conditions at which the density is equal to the density that is actually being experienced by the aircraft. Similarly, pressure altitude is the altitude at which you are flying such that the ambient pressure at that altitude is equal to the pressure at the corresponding altitude in the ISA table. That's all. It's a theoretical concept. We don't use it for any specific activity except when we report. So for example, when the pilot is reporting a pressure altitude of 20,000 feet, the information that he or she is conveying is that I am flying at an altitude at which the instruments which I am having with me are telling me that the density is so much. That's all. Sanket Bhatt, can you please give some more information about Qatar condition? Qatar condition is a condition that helps us to determine whether the flow is a lifting flow or a non-lifting flow. The condition basically tells us that the flow leaves the trailing edge of an aerofoil smoothly and that there is no velocity defect between the flow just above and just below the cusp at the trailing edge. Okay. So it's a very interesting condition because when you do numerical modeling, when you do numerical modeling of the flow, when you do CFD analysis of the flow, if you want to capture the physics, okay, because CFD is basically a numerical or a mathematical simulation of the flow field, but the lift generation or the drag generation happens because of physics. Okay, so to ensure that the physics of the flow is captured correctly in the mathematical simulation, it is very important to satisfy the physical condition of the Qatar condition at the trailing edge. So when you do numerical simulation and you don't apply Qatar condition, you will not get lift. You will not get the correct answer. Okay. So that's why it's a very important condition in lifting flows. So that's all I would like to talk about Qatar condition. The name has come from a German scientist called Qatar, who actually first gave this condition as a methodology or as a scheme to find out whether the flow is lifting or non-lifting. It's applicable only when there is a lifting flow. So I'm still waiting for people to type out their branches and their colleges and also which year they are so that I can. Okay, this Runge Kutta condition is not, no, they don't mix up between Runge Kutta and Qatar condition. They are two different things. Runge Kutta is a method, a time-dependent method for marching in a differential equation. It's a numerical method to arrive at the solution of a differential equation, but it has not to do anything to do with the Qatar condition for lift. Okay, so if you don't have any questions, at least let me know who you are and where you are from. So that will help me to get an idea about who are the students in my course who are more active, who take the trouble of coming for the interaction session, because there are close to 2,000 people attending this course. Okay, there are 2,000 students attending this course or registered for this course. but the number of students who are interacting is far less. Okay, it doesn't matter. If you're not a student, you're working with an airline, please tell which airline you are working for, where are you from, why are you interested in this course. Okay, Akhil, Akhil. Is there any adjustment of total angle of attack of aircraft by nose wheel? I'm asking this question by noticing fighter aircraft videos from YouTube. Many aircraft seem like nose down position. Well, see the length of the nose leg is the length of the nose leg. So Avinash Mishra, I can read your name already. So you don't have to say that you are Avinash Mishra from School of Aeronautics. You can just say that you are from so and so college. I would like to know which year you are from, because I recently visited your college. November last year, I remember last year, November, while I was traveling in Rajasthan with my family, I actually gave a talk in Nimrana about, I think, the NACDEC competition. So I don't know whether you were present that time in the audience, Avinash. Please confirm whether you were present when I interacted with the students. That was the first interaction I had face to face after the pandemic with students. So I was delighted and I was very excited because for about 2 years, I was interacting with students like this only online, okay, which is very frustrating and very boring. So therefore, I really like the suggestion by Mitra Aditya that we should have a face-to-face interaction session. So Avinash, kindly confirm whether you were present in the audience when I visited your college last year, and also tell me in which year you are in right now. Coming back to the question by Akhil. So Akhil, the thing is that the orientation or the nose attitude of the aircraft is decided by the designer based on the angle at which they would find. And moreover, remember one thing, that as the nose landing gear leg gets compressed, as the oleo leg gets compressed, the attitude of the aircraft might even change. But it's not a fixed number. It can, depending on the loading of the aircraft, depending on the CG position, the orientation could be different. So Avinash has confirmed that he's in third year and he was present in the interaction. I'm very happy, Avinash, to know that you were present. Okay, good. It's nice to know that students are interested to attend the sessions when we go out, and you have to actually thank Namanuddin for that particular session, because I remember I was traveling without a laptop and he was the one who made the presentation for me and mailed it to me on the day of the interaction session, and I could use that session to talk to the students. So Naman, thanks once again for doing that job at such a short notice. I think within a day or so, you were able to create the PPT and mail it to me, because of which I could interact about NACDEC with these students in Nimrana. Okay, KC Parashar is working with Air Asia India as a senior first officer, and he is up for command and want to expand knowledge before I apply for promotion. So very good, Captain Parashar. Very happy to know that even people who work in Air India, first officers, they are also attending my course on Introduction to Aerospace. It's very encouraging for us. Sanket Bhatt, he's a CAD PLM developer at Boeing, currently working on software development of 787 gap management issue. Okay. Wow. So these are industry professionals working in Boeing who are attending the course on Introduction to Aerospace Engineering. I am deeply honored and delighted. Some of my students, ex-students, are also working in Boeing in India, and they keep interacting with me. One of them used to work till recently for, I think, the software division or the IT division, and then he has now gone for higher studies. Okay. So you are the one who asked a question regarding the constraints on the flaps with altitude. So I'm not aware about any specific constraints on altitude because of flap deflection. I don't know. Maybe because of the low temperature, it may be a problem because of low temperature, but I don't know. I mostly know about the limits on the flap deflections because of the forward speed. Ziad Mullah is a fourth year BTech mechanical student of Father Roderick's Institute in Vashi. Very good, Ziad. We are very happy to meet you. Sanket is also very active in the discussion forum, which Naman is appreciating. So Sanket, thanks a lot. We need people like you to actively participate because you have domain specific knowledge with you, which you can share. And that is what enriches the course. See, we have to be very thankful to the NPTEL organizers who are giving a platform for interaction between people like me who are faculty members, teachers, with limited industry experience. I do have some experience, but many, many years ago. I'm out of touch now. I only have about 5 years experience in the industry. But there are people like Sanket, there are people like JC who are actually working professionals in this field. And when they interact in the discussion forum, that knowledge is so useful and so much enriching for everybody. So I'm thankful to them for taking the trouble of joining our course and also participating very, very actively. What about the other students? Could you please tell us where are you from and your background so that we get an idea about the students who are in the course? Because there are very few opportunities like this when we can interact with our students. Okay. Normally, the interaction happens on discussion forum, which is very impersonal. So this is the only forum where we can interact personally. And therefore, I'll be very happy if other students also can tell us, other participants in this discussion forum can tell us where they are from and what they are doing. Okay. There are around 12 people in the audience, apparently. So I'd like to know. Yes, we have about 12 minutes remaining, friends. Other people in the audience, maybe you can introduce yourself. Abdul Aziz, VVM, even Pratik Jalan, they're all there. So utilize the remaining time. So Ziad Mullah, since you are in Washi, it may be a good idea to visit IIT Bombay sometime personally to meet me and to have a face-to-face discussion. Just send an email and then we will work out the details of that. Sanket, will sudden gust, wing or gust can change angle of attack of the bank angle of the... Yeah, definitely. Gusts are rarely very sharp. Okay, they normally have some cosine behavior or some other kind of behavior. But there are certain situations where the gusts are very sharp and they will give very high delta NZ. So as you can see, the value of delta NZ because of gust is a function of wing loading. So higher the wing loading, lower is, lower the wing, higher the wing loading, lower is the delta NZ. Then lift curve slope, velocity of the aircraft in flight, and also the velocity of the gust and the lift curve slope. So yes, sudden gust can definitely change the angle of attack. Regarding bank angle, it's very difficult because for bank angle, the gust has to be so small that it has to attack only one wing. So, there can be transient disturbances, but usually the amount, because gusts are mainly because of the uneven heating of the air in the atmosphere. Therefore, it is very unlikely that only one wing is going to get a gust so much that it actually creates a lot of banging angle. So may not be there. Okay. Hariharan has confirmed that he's in second year mechanical engineering from St. Joseph's College of Engineering in Chennai. Uh, okay, great. And Mitraditya is saying that he has completed BTech in 2014 and he has worked on ALH on all versions in the army. And it's a third course in NPTEL. Very good. Very nice to know that you are in the army for last 2 decades and still you are interested in learning about basic fundamentals and about aerospace engineering. I would strongly encourage you to also register for my course on aircraft design, where we don't touch helicopters there, unfortunately, but we do touch very large aspects of aircraft design there. So I don't know, you may be already there in the course in aircraft design, and I'm going to follow my interaction after 15 minutes or so with the students of aircraft design. But very glad to know you and looking forward to interact with you sometime in person. Okay. Any other queries people have? Sanket wants to know any prerequisites courses required for aircraft design. Well, the prerequisite is only the course on Introduction to Aerospace Engineering, which you're already doing. Because, in that course, we cannot take the time to explain the various terms, nor can we go to the very basics. We straight away go to the design aspects. So, broadly speaking, if you have so much of experience in the industry, you don't have to worry. But this course is being repeated every year for the last few years. So if you have missed it this time, you can probably take it when it is offered next time. And for the information of the students, I'm also going to I'm also going to conduct a course on a topic which is my research area. It's called as lighter than air systems or LTS systems. I've just confirmed that I will be running that. I'll be running that course. In the next semester again. Um, so, so yes, there isn't much prerequisites. You should be able to basically understand the uh, terms and also have some basic idea about aerospace engineering and aircraft related topics, which you can get if you attend the course on Introduction to Aerospace Engineering. So that's all that is needed to attend the course on aircraft design. But for the course on lighter than air systems, actually there are no prerequisites. There are many students, even from the first year of BTech, who are attending that course and they give a feedback that they are able to appreciate and enjoy, because that area is an area which is not covered in aerospace engineering curricula all over the world. We are the only institute in the world, I think. I may be wrong, but as far as my information goes, we are the only institute in the world which is running a course, in the area of lighter than air systems as a dedicated course for university students. So therefore, when you offer that course on NPTEL, there is a lot of interest in that course. And I would encourage all of you who are interested in aerospace engineering to also consider taking the course on LTA systems. Nadeem Ahmed has a question. Why don't we use ram air turbines on aircraft when on the air to generate power and store it for later use and not just during emergencies? Because Nadeem, the ram air turbine will not be, it will not be able to take the load when you are flying at such a high speed. That is one thing. Second thing is, it is something that is required as a backup for emergencies. Okay. So we don't want to use it because it will create a lot of drag. And when deflect such a big thing outside from the aircraft during cruising flight or during high speed flight, you will get more harm than good. The power generated will be less than the drag power that is required to overcome the drag acting on the body. So therefore, I don't think it is useful at high speeds and at higher altitudes. Moreover, at high altitudes, the Raman turbine also will generate less amount of power because of lower density of the ambient air. So that's why we use it in emergency. It is stored inside the aircraft. It is brought out only during emergency. I mean, as a normal airline passenger, you will never come to know about ram air turbine. Nadeem Ahmed, I also want to know which college you are from and what branch you are studying and in which year you are. Pratik has a question. Difference between blade sweep and blade twist. Okay. Sweep is the angle given in the top view to the leading edge of the component. Okay. So if it is a blade, you look at it from the top view, and if you see that there is a general deflection, the general angle given from the normal, then that is sweep. Twist basically means that the angle at which the various cross sections of the propeller are facing the air changes along the length, then it is called as twisting. So sweeping and twisting are two different things. In twisting, the you may have no sweep in twisting, but in twisting the angle between the ambient air and the section of the propeller or section of the blade will be changing as you go from root to the tip. Okay, because it has got twist. It could be a geometric twist or it could be an aerodynamic twist. In the aerodynamic twist, the angle will not be changing physically, but the aerofoil will be changing, and that aerofoil will have a different zero lift angle of attack. So you can achieve twist by aerodynamic twist rather than geometric twist. And sweep, I told you, is a parameter which is apparent or visible in the angle of the lateral along the length of the blade with top view. Okay, Nadeem Ahmed, we are still waiting for you to confirm. Tell us where you are from and which year you are and what branch you are studying. If you are a student or if you are working somewhere, please share with us uh, where you are from. And the same goes for other students also who have not yet informed us. We have around 7 minutes remaining by my watch before we close this session. Hardly 5 minutes left. That is what Noman has confirmed. Yeah, Naman, sometimes I think the students, they do not have any specific questions to ask. They are probably just thinking what to ask. But if some of you are hesitating, then I would request you not to hesitate. As I mentioned, no question is awkward and no question is silly. Okay, Naman, you want to share the good news? Please go ahead. You can share the news. Oh, you're talking about the award I got. Oh, thank you so much. Thank you so much. Thank you so much for that, for sharing this information. Thank you, Bharti. Thank you very much for your comments. Actually, this is something which is a surprise for me. I don't know why Naman has brought out this particular thing in this session, but it's okay. Thanks to everyone for your appreciative comments. But we are here to interact and to answer your questions, not to appreciate or congratulate anybody. But it's okay. I accept all your congratulations with all humility. Uh, Kindly organize a live session in Mumbai. It will be great. All interested can come for a day or two. The problem with Mumbai is accommodation. Unfortunately, IIT Bombay has a very serious limitation on accommodation for outsiders. Even for our own students, we're not able to give proper accommodation. So accommodation is a serious problem. Arranging an event, etc., is very easy, especially if it is a weekend. We have the classrooms, we have the facilities available. And since we live on campus, most faculty members like me, we are lucky that we have got accommodation on campus. So therefore, we live on campus and we can definitely come during weekends and interact with the students. The only problem is that when outsiders come to IIT Bombay, we are not able to accommodate them. And that is a serious because Mumbai is a very expensive city. Okay, Ziad Mullah has a question. In a lecture, you spoke about aircraft that can change their sweep angle for flying at ultrasonic speed as it is required to reduce the drag. But why nowadays such aircraft are not used? This is not true, Ziad. They are used. See, what you are saying is called as morphing. Morphing is basically a scheme to change the shape of the aircraft so that it can present itself in the most optimal configuration. So morphing is being done, but you know, we may not, morphing can be done for two reasons. There could be a morphing for reducing the control moments or for making the control forces lower on the aircraft, or it could be for vibration control, or it could be for improving the aerodynamic performance, such as including the L by D ratio. Okay, so I have a student who is about to finish her PhD. She works as an engineer in Larsen and Toubro in the UAV Design and Development Division. She's a part-time PhD student and she is investigating morphing by span increase or decrease for a high altitude, long endurance unmanned aerial vehicle or a HAIL UAV to see the effect of that on increments. Okay, on the endurance. So yes, morphing is definitely being done. Right. So I think I have been given the signal that we have almost reached the end of today's session. By my clock, there's only about a minute left. So this is the last minute, guys, for any interaction that you want to do, because then I have to stop and I have to again interact with students like you at 5 o'clock for the next course, which is Introduction to Aircraft Design. So I think, yes, Naman, please, students should be active on discussion forum. And we will try to arrange an interaction session in IIT Bombay personally also. So with that, I'm going to stop today's interaction session. Thank you so much for joining and asking these interesting questions. And see you again sometime next month in the third and the last session. Thank you.